be analyzed against all the possible consequences and to see if it predicts anything else. And this predicts something else. If the Earth is moving this way, more particles will hit it from the front than from the back. If you're running in the rain, more rain hits you from in the front of the face than in the back of the head, because you're running into the rain. And so as the Earth is moving in this direction, it's running into the particles, rather, and running away from the ones that are chasing it from behind, so that more particles hit it from the front than from the back, and there would be a force also sideways whenever there was any motion. This sideways force would slow the Earth up in the orbit, and it certainly would not have lasted the at least 4 billion years that it has been going around the sun. So that's the end of that theory. Well, you say that was a good one, though. It got rid of the mathematics for a while. Maybe I can invent a better one. And maybe you can, because nobody knows the ultimate. But up to today, from the time of Newton, no one has invented another theoretical description of the mathematical machinery behind this law, which does anything else but say the same thing over again or make the mathematics harder, and at the same time doesn't produce some wrong phenomenon. I mean, they have, like this model does it, but it produces something which isn't true. So there is no model of the theory of gravitation today other than the mathematical form. If this were the only law of this character, it would be interesting and rather annoying. But what turns out to be true is that the more we investigate and the more laws we find and the deeper we penetrate nature, this disease, that every one of our laws is a purely mathematical statement in rather complex and abstruse mathematics. This is relatively simple mathematics. It gets more and more abstruse and more difficult as mathematics. And why? I haven't the slightest idea why. It is only my purpose in this lecture to tell you about this fact. In other words, it's my purpose in this lecture to explain, really, why I cannot satisfy you, if you do not understand mathematics too well, in trying to explain nature in any other way. It is the burden of this lecture, in fact, to just tell you the fact that it is impossible to answer honestly, the challenge of explaining in a way that a person can feel the beauties of the laws of nature without their having some deep understanding of mathematics. I'm sorry, but it seems to be the case. You might say, all right, then there's no explanation of the law. At least tell me what the law is. Why not tell me in words instead of in the symbols? Mathematics is just a language, and I want to be able to translate the language. And in fact, I can. And with patience, I think I partly did. I could go a little further and explain more detail. That this means that if it's twice as far away, the force is 1/4 as much, and so on, and can convert all these into words. I would be, in other words, kind to the layman, as they all sit, hopefully that you will explain something. And various different people get different reputations for their skill at explaining to the layman, in layman's language, these difficult and abstruse subjects. The layman then searches for book after book with the hope that he will avoid the complexity which ultimately set in even by the best expositor of this type. He reads the things hoping one after he finds, as he reads, a generally increased confusion, one complicated statement after the other, one difficult to understand thing after the other, all apparently disconnected from one another, and it becomes a little obscure, and he hopes that maybe in some other book there's some explanation the man almost made it, you see. Maybe another fellow makes it right. And I don't think it's possible, because there's another feature. Mathematics is not just a language. Mathematics is a language plus reasoning. It's like a language plus logic. Mathematics is a tool for reasoning. It's in fact a big collection of the results of some person's careful thought and reasoning. By mathematics, it is possible to connect one statement to another. For instance, I can say that the force is directed toward the sun. I can also tell you, as I did before, that the planet moves so that if I draw a line from the sun to the planet and draw another one at some definite period, like 3 weeks later, the area that's swung out by the planet is exactly the same as it will be in the next 3 weeks and the next 3 weeks and so on as it goes around the sun. Now, I can explain both of those statements to you carefully, but I cannot explain why they're both the same. So that if you don't appreciate the mathematics, you cannot see that the great variety of facts, the enormous apparent complexity of nature with all its funny laws and rules, each of which have been carefully explained to you.